At 300 miles above ground, NASA's International Space Station, ISS, is home to a microgravity laboratory where NIH researchers work closely with astronauts to perform biomedical experiments. These experiments conducted in the space station address such issues as to how bone and muscle deteriorate, how humans fight infectious disease, and how cancers grow and spread.
Well, it's a unique environment. It's one that many of the NIH-supported researchers are interested in the effects of gravity on cells. And it's not just bone and muscle cells, but all the cells in the body are affected by gravity. And that's an environment that is truly microgravity. It's not quite zero, but it's impossible to replicate on Earth.
It's the special microgravity environment and its influence on human health and disease that led to the 2007 partnership between NASA and NIH, allowing for a segment of the ISS to be used for biomedical research, holding immense opportunities for NIH researchers.
And I'm glad that people are now getting the opportunity to do these important experiments, because the microgravity on the space station is all we need for that problem. We don't need to go to the moon. We don't need to go to Mars to answer the question of how this new environment affects human life.
In fact, Dr. Zimmerberg began collaborating with NASA in 1994 when NASA provided NIH with a rotating wall vessel called a bioreactor. Even though this machine was used on Earth, it mimicked microgravity, allowing scientists to look at tissue cultures in a 3D format.
And the hit was that we discovered that human lymphoid tissue, which normally is the tissue that puts out antibodies when you get an infection, was unable to operate in this suspension culture. And we used a very simple tissue that everybody knows, that many kids have their tonsils taken out. And tonsils are lymphoid tissue.
After making this discovery here on Earth, Dr. Zimmerberg and his team initiated their first ISS project in space, taking their research to a real microgravity environment, where they could better understand why the communication between two main types of lymphatic cells, called B and T cells, do not function in microgravity.
But until we go all the way into space with some of these issues, until we begin to find out why microgravity is having an effect on cell-cell communications, when all of the calculations you can make in the world indicate that there's nothing in our cells or tissues that should respond to microgravity at all. It's a central mystery, and that's the real payoff.
Since the actual experiments are being performed by NASA astronauts, not NIH researchers, Dr. McGowan says communication and early-on training is key.
So we designed a mechanism that's really two-stage, that enables us to bring land-based scientists together with NASA experienced technical people to enable the feasibility of experiments and the packaging of experiments, and then there'll be training in Houston.
NIH's goal is to reach out to more NIH-supported investigators in a variety of disciplines across the country, encouraging them to send projects that can be done on the ISS.
So NIAMS worked with 7 or 8 other institutes who joined us in this particular interest, and we put a program announcement in the Guide to Grants and Contracts telling investigators all over the country that this is a great opportunity, and we would encourage you to send us some projects that can be done.
For more information on the collaboration between NASA and NIH, and to learn more about funding, please visit NIAMS's website. This is Natalie Gianosa for Eye on NIH.